Jacoby-Tarbox offers 3 indicators in all of their assemblies. The 3 indicators are a rotary style. The rotary sight flow indicator is designed for movement under continuous flow. There's a minimum and a maximum. So consult Jacoby-Tarbox literature for the details. The flapper type indicator is an indicator that is going to be used when flow is changing and intermittent, so it'll swing back and forth, looks like a little check valve on the inside. It also is only suitable for flow in one direction. So you could have flow going, for my purposes, right to left, but flow from left to right, while it would not seal, it will certainly restrict flow going in the opposite direction. The orientation is also limited to vertically upward only. If you were to install it vertically downward, the flapper would hang open and would not yield any information that would be useful. Rotary style could be left, right, up, or down, so any orientation for the rotary style. The casting used for flapper types can also be used for a drip tube indicator. Drip tube can be used, again, for flow only from one direction. If it is a liquid line that's less than full, you would use it in the horizontal application, so the liquid be up in front of the glass and roll off, as opposed to flowing down, never be seen, and off it goes. It also can be installed vertically downward. These would be for condensable gases, such as steam, where you look at how wet the steam or the process was by looking at how much moisture would gather around the end of the drip tube and then fall away. The last option is really to have no indicator at all. Jacoby-Tarbox Sight Flow indicators are designed in accordance with ASME-B 31.1 and 31.3 requirements, using the wall thicknesses dictated by B16.5, which of course is also derived from B31.1 and 31.3 as the base for the calculations. One thing people always point out when they look at a sight flow indicator, especially Jacoby-Tarbox, is the drastic difference between the size of the fasteners holding the assembly together versus the size of the fastener that would be used to mount it in a process line. Several years ago, the units were completely redesigned so that we would have better durability of the assembly whenever you had thermal cycling or vibration. These are things that often cause fasteners to loosen because there's no real spring in the assembly. Rather than add extra components, such as lock washers or spring washers, engineers at Jacoby-Tarbox designed the fastener to actually be the spring element. Not so much you have to replace them after use, but so that they could handle the thermal cycling and vibration that exists in many applications with piping, without having to go through and constantly recheck the torque within the assembly. The loads across a retainer are singular. You have simple tension. The loads required whenever you bolt in a process line are not just tension, but also shear concerns and so on. So the need for the bolt is to go much larger. Lastly, whenever you bolt 2 flanges together, keep in mind you are bolting them down to be a permanent joint, and you have the ability to crank down really until you physically stretch the bolt. We have glass in our assembly. The glass in the assembly prohibits you from going to these excessive torques, and the torques are always going to be the minimum required to create a seal and have nice longevity of the assembly for the various processes. So, next time you look at a sight flow indicator and question, why are these bolts so small? There really is design reasons behind it. If your application requires an FM approved version of a sight flow indicator, we would upgrade the unit from having a single window design, 1 per side, to having 2 windows per side. Within this holder are actually 2 individual, independently mounted pieces of glass. These are used both the front and the back of the assembly. That would be the FM approved configuration. Each of the windows can independently hold all process rated conditions, and should an external impact come and damage the outer window, the inner one is actually holding the process. Should an unknown upset condition happen within a process due to corrosion, something unforeseen, and the inner window were to go away, the outer one then takes over and completely handles the process. Thus, its ability to handle service in an FM approved application.